Hello students, welcome to the maths class of Navdeep Agarwal. Today I am going to explain exercise 6th G. In last video I explained exercise 6th F. Now exercise 6th G. In this exercise you are going to study 4 points. These 4 points in front of you I have written. One by one I am going to explain each point. First point is determinant of a square matrix. So students, to understand this, you see here, in simple way I am telling to you. Suppose you are having a square matrix. A equals 2, 3, 4, 5. Then corresponding to this square matrix, its determinant will be 2, 3, 4, 5. Like this, you can understand for every square matrix, its corresponding determinant. How can you find? You can change this big bracket into vertical bars. Then corresponding determinant you will get easily. And this determinant you can expand in chapter number 5. I told you 2 5s are 10 minus 3 4s are 12. Its value will be minus 2. So as you associated with this matrix, with this given matrix A, there is a real number minus 2 which is called its determinant. Or in simple way, as I told you before, if any square matrix is given, so in place of this big bracket, you can convert it into vertical bars. Then corresponding determinant you will get, and you can expand this determinant. So like this, for every square matrix, I'm telling you again and again, for every square matrix you can find its determinant. Next point is, if A and B are square matrices of same order, then determinant of AB equals determinant of A multiplied by determinant of B. This is the property. If two square matrices of same order, means A and B both should be of order 2, A and B both should be of order 3, A and B both should be of order 4, like this and so on. Then in that case, determinant of product of AB equals determinant of A multiplied by determinant of B. So this property, with the help of this property, you can find directly determinant of AB. Determinant of A you can find, determinant of B you can find, and then you can write determinant of AB equals determinant of A multiplied by determinant of B. Next thing, singular and non-singular. It is very easy point. Singular and non-singular. Suppose that you are having a square matrix and its determinant you are finding. If value of its determinant is equal to 0, then it will be singular. Otherwise, it will be non-singular matrix. What I told you, one more time I am telling to you, if you are having a square matrix A, its determinant A you find, suppose its value is 0, determinant value is 0, then you can say given matrix is singular matrix. Otherwise, if it is not 0, determinant is not 0, then you can say given matrix is non-singular matrix. Now next point is coming, invertible matrix and inverse of a square matrix of order 2. Yes, especially I have written inverse of a square matrix of order 2. In exercise you are going to study how to find the inverse of a square matrix of order 2, only of order 2, not order 3, because that inverse you will find in next exercise, 6th H exercise. In 6th H exercise you will find the inverse of square matrix of order 3. In this exercise only, inverse of square matrix of order 2. So first of all, what is inverse, what is invertible matrix, and how can you find the inverse of a square matrix of order 2? So answer of all these questions I am going to give. You see, Suppose that you are having two square matrix A and B of same order. A and B of same order. Again and again I'm saying A and B of same order. And suppose AB equals BA equals I, means product of A and B equals product of B and A equals I. I means identity matrix or unit matrix, you can say. Suppose A and B both are the matrix of order 2, as I am taking of order 2 matrix, square matrix of order 2. So AB equals BA equals, it will be I2. If A and B are the matrices of order 3, then AB equals BA equals I3 it will be, not I2, if A and B are of order 3. So if such type of case exist, product of AB equals product of BA equals I3, then you can say A is the inverse of B and B is the inverse of A. A is the inverse of B and B is the inverse of A. But condition you will have to remember, this product AB equals BA. Both should be equal and must equal to I. Must equal to I. Then you can say A is the inverse of B and B is the inverse of A. Now how can you find inverse of a matrix of order 2? So you see here, suppose A you are having 2, 3, 4, 5. This is A. So how can you find its inverse? First of all, you will have to check this matrix has inverse or not. Because students, all square matrix, they do not have the inverses. All square matrices do not have the inverses. Some square matrices have the inverses. So how can we find the given square matrix has inverse or not? So for that I'm telling to you, you find its determinant. Determinant A. This determinant A will come -2, just before I found. So this determinant, if it comes 0, then the given matrix A does not have inverse. If it is not 0, then it has the inverse. So in this case it is not 0, so it has the inverse. How can you find inverse? So A inverse equals 1 upon determinant A into adjoint A. Adjoint A. What is adjoint A? I will tell you. How can we find adjoint A? In this video only I will tell you. So first of all, one more time I'm telling to you, every square matrix does not have inverse. To check how to find means to check the given square matrix has inverse or not, you find its determinant. If its determinant is not equal to 0, then only it has the inverse. Means if the given matrix is non-singular matrix, because for non-singular matrix determinant is not equal to 0. And if the given matrix is singular matrix, when it will be singular? When its determinant will be 0. So if it is non-singular matrix, then you can find its inverse, otherwise you cannot find its inverse. Now come to some example and some properties also. So there I will tell you, and how to find inverse. I was telling to you adjoint A, you see here, as A equals, just before I took 2, 3, 4, 5. So adjoint A, how can you find? You can interchange. It is the method for square matrix of order 2 only. It is the method which I am telling now of square matrix of order 2 only. You interchange the element of this leading diagonal, means you can take 5, 2, interchange, and you change the sign of other elements. It will become -3 and it will become -4. This will be adjoint A for square matrix of order 2. For square matrix of order 2. And divide this by determinant A. Determinant was coming, determinant A was coming -2. So -2. So this will be the inverse of A inverse, you can say inverse of matrix A equals A inverse. So like this you can find the inverse of square matrix of order 2. Some example will also come, I will tell you. One more property is also there. If you are having determinant of Ka, so it will become K to the power n determinant of A. Means suppose that A is a matrix, given matrix of order n. In that case, and um, you are multiplying matrix A by K, then its determinant, how can you find? So Ka equals K to the power n determinant of A. One example will be there, I will tell you. Now you see, here procedure I told you, check whether the inverse exists by finding determinant A. The inverse will exist if determinant A is not equal to 0, if the given matrix is non-singular. I told you. Interchange the entries on the leading diagonal and change the sign of entries on the other diagonal. Once again, I'm telling you, this is the method to find the inverse of square matrix of order 2. For square matrix of order 3, then I will tell you one more method in next exercise. Divide the result of step 2 by determinant A. So here you can see one example is given 67. A is given 1, 2, 3 minus 1. A inverse you have to find. So first of all, determinant you are finding 1 1 are 1 minus 1, 2 3 are 6 minus 6 minus 7. So it means that it is not 0. So given matrix is non-singular matrix. So A, its inverse exists. A has the inverse. So A inverse equals 1 upon determinant A, and you change the entry of leading diagonal, you have changed, and sign of the elements on the other diagonal, so you have changed the sign. So you can see, now divide it by minus 7. So answer is coming, you can see here, 1 upon 7, 2 upon 7, 3 upon 7, minus 1 upon 7. So this is the method to find the inverse. Now you have to check this inverse is correct or not. So you this A inverse and multiplied by A. So you can see here, it must come I, and I2 should come because the given matrix is of order 2. So you are finding, you are multiply, you know how it is done. So this multiply is coming 1001. So finally I2 is coming, so it means that your inverse is correct. One more example is there, you can see example number 64. Show that it is a singular matrix and hence no inverse exists. So you can see it is a singular matrix. If determinant you find, if determinant is 0, then it is singular matrix. So you are finding inverse. 3 tens are 30, 6 fives are 30, 30 minus 30 is 0. Determinant is 0, it is singular matrix. So that's why this given square matrix does not have any inverse, does not have not any inverse. So this square matrix is not having inverse, because inverse is only unique. Only for each square matrix, those matrix have the inverses. Only one inverse exists. Only one. Next is coming adjoint. This adjoint of a square matrix, it is for the matrices of order 2, of order 3, of order 4. This method which I am telling to you, if you want to find the adjoint. So first of all, what is adjoint? You see, this is a square matrix of order 3. Here elements are given. In chapter number 5, I told you about cofactors and minors. So remember cofactors. So for every element of the given square matrix, you find the cofactors. And in place of element, you write the cofactors of all elements. You can see here. In place of elements of given matrix, you write the cofactors of every element you have written and take its transpose. You can see here I have made circle here. So adjoint A equals transpose of the matrix of cofactors of elements given in the given matrix, in the given matrix. So adjoint of a square matrix equals transpose of the matrix of cofactors of elements of given matrix. So this is the adjoint A. This is matrix of cofactors and its transpose you are taking. So like this it will come. So definition is also given. The adjoint of a square matrix is the transpose of matrix obtained by replacing each element of A by its cofactor in determinant A. One more important property is coming. You can see here. You can see if A is a matrix of order 3, K is any number, then adjoint K equals K square adjoint A. So it will become one less power. If order is 3, then power will be 2. If order is 4, then power will be if order is 4, then power will be 3. So like this you have to remember. Next one example is there. You can see find the adjoint of matrix A 2 4 1 minus 1. Now this is the matrix of order 2. So you can take cofactors of each element. Cofactor of 2. 2 means this is the first element of first row and first column. So you can say you can take A11 equals 2. So you can take its cofactor capital A11. This is element. Small a11 means element of first row and first column 2, and capital A11 means cofactor of element in first row and first column. So you are taking this row cancel, this column cancel, minus 1 will remain. So minus 1 will come, but you can see 1 1 means 1 plus 1 2. So it is even number, so that's why it will be positive, means I told you that time how to find cofactors. So 1 1 means even number. So whatever number this number is remaining minus 1, outside this minus sign will not come. Now here for second element 1 2, 1 2 you can see again. This is the element 1 2. So for this element cofactor you are finding this cancel, this cancel. So it should be 4. So it is 4, but they are giving minus 4 because 2 plus 1, this 2 plus 1, 3, and it is odd number. So odd number you can see here minus 1 to the power 3. So that's why they are taking minus 4. So you no need to take minus 1 to the power 1 plus 1 like this. No need to take. Directly you can see here what is the subscript. If this subscript 1 plus 1 2 even, it is coming even, then with the element you will not take minus sign. If it is coming odd, then you will take minus sign. Here also you can see 2 1. 2 1 means 3, odd number. Odd number means minus sign will come. So here with 1 minus sign is coming. 1 how it is coming? This cancel, you can see again. This cancel, this cancel. Then this 1 remains. This 1, and with this 1 this minus sign is coming. Due to this 2 1. Now 2 2. So with the help of 2 2 you can take this cancel, this 2 will come. This 2 is coming. Now adjoint, how can you find? First you take matrix of cofactors. So A11 minus 1, A12 minus 4, A21 minus 1, A22 2, and its transpose here you can see. Its transpose means interchange rows and columns. So like this you are getting its adjoint A. So in this way you can find adjoint. Next example is coming. You can see find adjoint A where A equals 1 2 minus 2 minus 1 3 0 2 5 1. So in the same way as I told you in previous example, But one more time you see A11, cofactor of A11 it is written. So element of first row and first column. So you can see this is the element 1. Its cofactor you are finding. So this row cancel, this column cancel. Clear? Now what remains? These four numbers remain. And you know how to expand these four numbers. 3 ones are 3, 5 multiplied by 0, 0. So 3 minus 0 you can see here. 3 ones are 3, 5 multiplied by 0, 0. So it is coming 3. But you can see here A11. I told you 1 means 2 even number. So that's why whatever solution is coming with this solution, negative sign will not come. Now second, you see, with the help of second cofactor you can understand what I'm saying. So you can see 1 2 1 2 means element of first row and second column. This is the element of first row and second column. So you can delete this column in which it lies, and you can delete the row in which it lies. So this row and this column I have deleted, you can see here. Now four numbers are remaining. These four numbers you can see: 2 5 minus 2 1, 2 5 minus 2 1. So you can expand these two numbers. 2 ones are 2, 5 twos are 10. So 2 minus minus 10 plus 10, 2 minus minus 10. So it will come plus 2 plus 10, you can see here in the bracket. Now outside this bracket minus sign is there. So with this I told you 1 plus 2 is 3, which is odd. So with the help of this odd number, due to this odd number, this minus sign is coming. If it is not odd number, then minus sign you will not take. So this will become plus 12, sorry, minus 12. Now in the same way you are finding cofactors of all elements: A11, A12, A13, A21, A22, A23, A31, A32, A33. Now first of all you take the matrix of cofactors. So matrix of cofactors A11 is whatever it is: A12, A3, A13, A21, A22, A23, A31, A32, A33. Here you can put the values and you can take transpose. So this answer will come. Or you can do, first you take transpose. They are taking transpose first. So A11, A12, A13, this row they are taking in column. You can see this second row they are taking in second column, this third row they are taking in third column. So first they are taking transpose. Now they are putting the value of A11, A21, A31, these values they are putting. So like this you can find adjoint A. Now one property is coming with adjoint A, this property, an important property, an important relation between square matrix and adjoint A. You can see adjoint A into A equals A into adjoint A equals determinant A into I n is written. N is the order. Order means whatever order is given of matrix, of given matrix. Suppose matrix A is of order 2, then here it will come I2. If A is of order 3, then here it will come I3. So like this you can take, this property can be applied in many questions, I will tell you. So you see one question is given: A is 1 3 2 4, verify adjoint A into adjoint A equals adjoint A into A equals determinant A I2. So you are having this A adjoint A, first you find, because you need adjoint A to satisfy this property. So adjoint A, as I told you, A11, A12, A21, A22, its transpose. It is coming like this, they are finding cofactors as I told you just before. Adjoint A into adjoint A, product you are taking. This is A, given matrix, adjoint A which you have found, you multiply, you know how to multiply. So it is coming minus 2 0 0 minus 2 can be taken out common. adjoint A into A, this product you find. In previous product, A into adjoint A, now adjoint A into A. So this product is also coming minus 2, 0, 0 minus 2. Now determinant A into I2. Determinant A, you know, for the given matrix, determinant A 1, 3, 2, 4 like this, and I2 is 1, 0, 0, 1. Determinant A is coming minus 2, 4 minus 6, minus 2, you multiply. Now you can see these three steps. This one, and this one. All are matching. So it means that A into adjoint A equals adjoint A into A equals determinant A into I2. Next is coming, one more example is there. Given that A equals this, A into adjoint A equals K 1, 0, 0, 1. Here you can see how can we solve this example. First of all, determinant A into adjoint A into adjoint A equals determinant A I2, because it is a matrix of order 2. So here it is given A into adjoint A K and this I2. So you can take this K into I2 means this K is adjoint A. Sorry, this K is determinant A, because this is equal to determinant A I2. So here it is given K I2. I2 cancelled. So K equals determinant A. K equals determinant A. So you find the determinant. Determinant will come cos square minus minus sine square. Cos square x plus sine square x. So it is coming 1. So it is coming 1. K equals 1. So like this you can solve, but you have applied the property, this property. A adjoint A equals adjoint A into A equals determinant A I2. Next is coming, one more property is there. You can see, if A is a 3 by 3 non-singular matrix, then determinant of adjoint A. Now you are going to study determinant of adjoint A. Determinant of adjoint A equals determinant of A square. So you can see here one example they are taking. No example is not there. So you can see this property. If you are finding determinant of adjoint A, so first of all you need what is the order of given matrix A. So if given matrix A of order n, then you will take determinant of n minus power of determinant of A is n minus 1. So this property, determinant of adjoint A equals determinant of A its power n minus 1, means if order is 3 then power will be 2, if order is 4 power will be 3, if order is 5 then power will be 4, 1 less power. Next, you can see this. If A equals 1, 2, 3, 3, 1, 2, 1, 0, 3, find the value of adjoint A into A without finding adjoint A. This time in the question, in the example, they are saying adjoint A you don't have to find. Without finding adjoint A, its value you have to find. Just before I told you the property adjoint A into A equals determinant A into I3. Why I3? Because here given matrix is of order 3. So determinant A you find. Determinant A, as I told you in chapter number 5. So it is minus 14. So adjoint A into A equals determinant A into I. So adjoint A into A minus 14 I. I is of order 3. 1, 0, 0, 0, 1, 0, 0, 0, 1. So by minus 14 you multiply. So this is the value of adjoint A into A without finding adjoint A. So this property is very useful if it is said in the question, without finding adjoint A you find this. Next, one more theorem is there. If A and B are two non-singular matrices of same type, you can see here, then adjoint AB equals adjoint B multiplied by adjoint A. I told you, in one case I told you this property. It was in case of transpose. Transpose of AB equals transpose of B multiplied by transpose of A. In the same way, adjoint of AB equals adjoint B multiplied by adjoint A. So this property is also useful. You have to remember this property. Next is this example. You can see, if A is invertible matrix, invertible matrix means its inverse exists, of order 3, order of matrix A is 3, determinant A equals 5, find the value of adjoint A. Determinant of adjoint A, just before I told you the property, how can you find determinant of adjoint A? Determinant of adjoint A equals determinant of A and its power. Determinant of A and its power, because A is of order 3, so its power will be 1 less. So adjoint, determinant of adjoint A equals determinant of A square. So determinant of A is given 5, so 5 square 25. So like this you can find. Next, it is coming. Now I think I have completed this topic. Adjoint of square matrix I have told you. Example also I told you. This example also I told you. This property I told you. This property I told you. This property. So students, with the help of these properties and this inverse which I told you, singular and non-singular matrices, how to find inverse of order 2, you can solve all the questions of exercise 6th G. And after this exercise, in next video I am going to tell you how to find inverse of matrix of order 3. So I hope you have understood all the points